A metallic sphere A of radius small a carries a charge plus q. It is brought in contact with the uncharged sphere B of radius small b. The charge on the sphere A now will be, what is the charge? This is the thing we are going to solve it explicitly now.
First, we need to picturize the problem. They are given the metallic sphere A of radius small a. It is charged with the plus q. Suppose I am taking the metallic sphere. This is a capital A. This radius is small a. The total charge in the metallic sphere, it is plus q. Maybe it has distributed on the surface also, the plus plus plus. The total charge in the whole metal sphere, it is A. So we can write what is the capacitance of the in the metallic sphere. That should be equal to the charge divided by volume, or you can say it's charge by volt, the total charge divided by volt, or the capacitance equal to the total charge divided by the voltage is volt. The potential is nothing but 1 by 4 pi. V means it's a potential 1 by 4 pi epsilon naught. The total charge divided by the radius of the, suppose if you are calculating the potential at the surface, that should be equal to 1 by 4 pi epsilon naught q by a, the radius. This is a potential on the sphere. So you can cancel this q. So if you are reciprocate, it will give the capacitance equal to 4 pi epsilon naught a. So this is the capacitance of the metallic sphere of radius c. So in the same manner, you can define the initially they are given the another metallic sphere. The total charge is 0 initially. That sphere radius is small b. You can name the sphere is using the capital B. Suppose if you are touching these two sphere, what would happen? Suppose if I am touching these two sphere, this is sphere A, this is a sphere B. Maybe here I am putting positive charges. In general, it can be negative also. You can put some charges. So the capital Q, what would happen? It this suppose if the Q is positive charges, it has to distribute it. If you are touching the metallic sphere B of radius small b, this is a B sphere with the A of radius small a. What would happen means, the charges on the metallic sphere A has to be transported or distributed to the metallic sphere B. Now the new charge on the metallic sphere A, you can call QA. The new charges on the metallic sphere B, that means the accepted charges or transported charges, it's QB. So in general, you can define the total charge is equal to the initial charge on the metallic sphere before the contact. That should be equal to the QA plus QB. This is a charge conservation. That means we never lost any charges due to the contact. The total charge remains conserved quantity. So the capacitor now you can define, because capacitance it is depend on the radius only. So it has to be the same. The capacitance of the first charges sphere, that should be equal to 4 pi epsilon naught A. The capacitance of the charges sphere B, that should be equal to 4 pi epsilon naught B. These are the two capacitance of the metallic sphere A as well as the metallic sphere B. You can take, this is equation number 1, this is equation number 2. Now what if we want to find means, they are asking the charge on the sphere A after the contact, how much amount of the charge on A. So we need to qualitatively discuss this problem. After touching these two sphere, the potential on the sphere, that must be equal to the potential on the sphere A. So this potential, if it is equal, you can call in general the potential that should be equal to the Q by C. So that means the QA by C as well as Q by B CB. So this is the potential. So once if it is charging, it will be equilibrate. The potential on the two metallic sphere, this will be equal. In general, the potential can be represented as a charge by the capacitance. In the metal A, it's a QA by CB. In the metal B, QB by CB. These two potential will be equal. So they are asking what is the final charge on the sphere A. So you need to write this equation in terms of the QA. That means the QB also you have to convert into QA. So QA by CA, here actually it is CA, that should be equal to QB. If you are just using equation number 1, you can write the QB, that should be equal to the capital Q minus QA. So capital Q minus QA by CB. We know what is the CA/CB, the capacitance on the each sphere. So one more equation you can write it here, or we can move it here. So QA divided by the capacitance on the sphere A, 4 pi epsilon naught A Q minus QA. This is a QB charges. The capacitance on the metallic sphere B, it is equal to 4 pi epsilon naught B. Now we want to calculate what is a QA. Just we have to rearrange this expression. Before that, you can cancel 4 pi epsilon naught, 4 pi epsilon naught. Suppose if you are rearrange it, it is QA times B, Q minus QA bracket. If this A goes that side, it is times A. Then you got to multiply this on Q times A minus QA times A, QA times B. Rearrange the QAs are one side. Actually this is Q times the A, the radius of the sphere. If you are rearranging this one, QAB plus QAA, if this is going that side, then it will turn out to be plus Q times the A. Take the QA commonly out, QA, then inside it will be B plus A or A plus B, that should be equal to QA. So the QA, the charge on the sphere after touching, that should be equal to A by A plus B times the total charge, the initial charge. So this would be the answer. It is simplest calculation. We can do it once if you know the capacitor on each sphere as well as the potential.
From the above discussion, we got the answer AQ divided by A plus B. The answer B is the right answer.